Hi everybody, let's describe substances. So here are the official objectives for 4A. Please read them, know them, love them, learn them. Okay, so elements come in two main forms. You could have single elements, which are just atoms, or diatomic elements, 2 atoms per molecule. There are some other types of elements, but those are the two main that we're going to look at. But what do you notice about them? These are all the same. That's a pure thing. These are all the same, but they're bonded together. So it's still an element because the blue one and the blue one are the same atoms, but it's called the diatomic element. And here are the 7 diatomic elements that you're going to have to know. So elements are pure and have unique properties. So compounds. Compounds are also pure, but they have 2 or more elements bonded together. So here's some particle pics of a compound and a compound. Okay, so the compounds have new properties than their elements that make them up. So hydrogen is an explosive element. Oxygen burns, but H2O puts out the fire. So these are the elements that make up water, but once you have water, H2O, it has different properties. Okay, here's another example. Sodium is a shiny metal. Chlorine is a toxic gas, but when you put sodium and chlorine together, you get white crystals that taste great on fries, also known as sodium chloride or table salt. So this is a particle of a compound because it's 2 different kinds of atoms bonded together. This is 3 atoms bonded together, but it has totally different properties than the blue and the red if they were by themselves. Okay, compounds versus elements. Elements are as simple as it gets, everybody. Every particle is the same, so it's pure, with only one kind of atom all the way through. So if that's a hydrogen atom, it's hydrogen everywhere, wherever you look. If you want a list of the elements, go to the periodic table. Compounds, every particle is the same, but it has 2 or more bonded elements. It's much different than the elements that make it up. So water again, H2O, you need a chemical process to get back to its original elements. And that's what we did when we did electrolysis. All right. But again, hydrogen, the element, causes explosions, or it explodes when you burn it. Oxygen burns, all right, and causes things to burn, but water puts out fire. So mixtures are very different than elements and compounds because they are not pure. Mixtures, not pure. All right. It's a blend. It's a blend of properties, so nothing new forms. It's just a mix of different elements or different compounds or different elements and compounds, and it gets pretty complicated. But the pieces of a mixture keep their own identity. So here's a particle picture of a mixture of 2 elements. So we have the red elements and the blue elements. So say this is sulfur and that's iron. They're different atoms, so they have different identities, and they're not chemically bonded. Okay, and it's not pure because not every piece is the same as every other piece. So here's a particle picture of 2 compounds in an element. See if you can pick out the compounds. Wait for it. Compound. So there's 2 different kinds of compounds. Element. So all of those pieces have a different identity, and they keep their identities. Okay. All right. So mixtures are fairly simple to separate. I mean, depends what you consider simple. But one way to separate a mixture is by filtration. And the reason that works is because one part of the mixture is bigger than another. So we use filtration. Here's a funnel that we use for filtering. There's paper in the funnel. Okay. Here's some dirty water. Here's some dirt in the water. So as it goes through, the water comes through, but the dirt gets stuck. Okay. So we've filtered out the dirt, and we got clear water in the beaker. And that's this is called a filtrate, and we've just separated the parts of that mixture. Okay, so what helps them? The different sizes, right? Some things can go through filter paper if they're really, really small. Okay, but other things can't go through the filter paper and they get stuck. Okay, all right, distillation is another technique to separate stuff, and the property we use is boiling point. Okay, so here's a mixture of the chemicals acetone and water. Now, we saw from our handy dandy peek data table that acetone and water have different boiling points and melting points, okay, on the data table. So if we have a mixture of them, we start heating them up, the thing that has the lower boiling point will start to boil, and then remember, temperature doesn't change during the phase change of boiling, so all the acetone turns into a gas, gets cold again in this thing called a condenser, and then comes over here, and then we have acetone. All right. So then once all the acetone has boiled off, then the temperature in the container can go up, but then this time it's not acetone anymore, it's the water. Okay, so water's boiling point is higher at 100. Acetone's boiling point is, I think, somewhere about 58. I'm trying to remember that from memory, but okay. So here's a graph of what it might look like. So we have both particles heating up as liquids, moving faster, moving faster, moving faster. We get to the boiling point of one of the substances, and it boils. Look, stays flat, flat line, flat line. All right. And then after that, both substances are still heating up, but this is still liquid. The dark pieces are still liquid, and the other ones are the gas of the acetone, so it's not in the container anymore. And then we get to the boiling point of the second liquid, and we're all set. So magnets can also separate mixtures. So pure substances that are magnetic are attracted to the magnet. You know about iron? Iron is a pure substance attracted to the magnet. Okay. If a compound has iron in it, like iron oxide, also known as rust, it won't attract a magnet because iron loses its properties of iron when it chemically bonds with oxygen. But if so the property of magnetism changes when iron bonds chemically with other things. Okay, but if it's pure iron, we can use the property of the fact that it's magnetic to pull it out of a mixture. Compounds are not so easy to separate because you have to break the bonds with a chemical reaction like we did with the electrolysis of water. So to get us another graphic of this describing substances, we have matter. Matter can be pure or matter can be a mixture. If matter's pure, it can be elements where every atom is exactly the same as every other atom. It can be compounds where every piece is the same as every other piece, but within the piece are chemically bonded elements. Okay. So then you can have mixtures. Mixtures are not pure. They could have different proportions, different percentages. You could have a mixture that's really, really well mixed, very well mixed, and it's called homogeneous. Or you could have a mixture that's not well mixed, and it's called heterogeneous. Okay. So there's different kinds of mixtures too, and they could be different proportions. You could have half of it, or you could have 3/4 of it. It'd be one thing, and or 1/3, 1/3, 1/3. Okay, so look, it's a challenge. Pure substance or mixture. So we're looking in this container. We see a blue kind of atom, all right, and then we see 3 red atoms bonded together. So this is an element, okay, and this is a different element. How do I know? Because they're different kinds of atoms, right? So what is this in this container? It's a mixture because there's different, not every particle is the same as every other particle, and it's a mixture of 2 elements. All right, looking in this container, we see this piece, this piece, this piece, like 4 pieces are identical to each other, so this is pure. Then, if it's pure, we should be able to decide, is this an element or a compound? Well, this has 2 different kinds of atoms bonded, so this is a compound. Okay, it's a pure compound. Compounds are always pure, and there we go. Okay, so to review, we got to ask questions to classify matter. Are all the particles the same? Then it's pure. Do the particles have more than one element? Then it's a compound. Definite ratio of varied. If it's varied, then it's a mixture. All right, differences in properties can help separate mixtures. Chemical reaction can separate a compound, and elements cannot get more simple. Okay, that's it. Here are the objectives again, and we're done.